All right, we're going to talk about perfect squares and exponents today. Okay? Here's a definition for a perfect square. If I'm writing, you're writing. A perfect square is a number whose square root, and we'll talk about what some of these words mean in a minute, square root is a whole number. I want to draw the little symbol for a square root here. It kind of looks like a V, but it goes just a little higher and comes out. So it's kind of a combination between a V and a division sign. Okay, that's kind of what it looks like. Right? That's the square root. And we'll talk about what each of these mean. So a perfect square is a number whose square root is a whole number. Now I'm going to skip ahead and pull out my 100 square blocks here. Well, let's go to jump ahead. No. In a minute you're going to get one, but all right. What is, in your words, what does a perfect square look like? It has equal sides. So if I measured the bottom and it was 2 units, what would the side be? Okay, if I measured something and it was 10 units across the bottom and it was a perfect square, what would the top be? 10 units. So let's look here in this drawing. If I make a perfect square in these blocks, and I'm going to use a 2 unit square. So that means it's going to be 2 down and 2 over, right? So I'm going to shade in those columns and rows. So I want to change. I want to go to a crayon here, and we're going to color him in. No, this is okay. How many blocks do I have colored for this perfect square? 4. So what might a perfect square of something with a unit of 3 look like? So I'm going to color 3 over and 3 down. So how did you get that? Okay, you can count the boxes. What's another way you could do it? I can multiply. So this was 3 and 3, so that was 9. So if I said I want one that has 4, how many blocks would I shade in? 16. And how did you know that? 4 times 4. So I'm going to go back to my paper. A minute ago we said we just multiplied a 2 by 2, and we got 4, correct? And we shaded in a 3 by 3, and I got 9. And then we didn't shade in, but using the same thought there, we know that's 16. Now, those are perfect squares because we saw that they were drawn as perfect squares, correct? Now, my definition says that the square root of those numbers has to equal a whole number. Now, square root, remember it's a V with that long tail, and I'm going to put 4 underneath it. Want 2 numbers that are the same, multiply together to give me 4. 2. So I'm going to rewrite this. It says 2 times 2. Does everybody agree that 2 times 2 is the same as 4? Okay, so I haven't done anything. I just made him look different. Hold on. Now, this square root tells me it's kind of like an admission gate. You go to Dollywood and you have to have a ticket before they let you go through, right? Same thing here. The square root is my admission gate. I have to have a pair of the same thing before it can come out. So do I have a pair of the same set of numbers. I have two 2's, correct? So now that 2 comes out from underneath that square root looking like a 2. But he has to have 2 of them before I come out. So look at your 9. What do we multiply together to get 9 that's the same? Do I have 2 of those 3's? So now he's able to come out from underneath the square root to look like a 3. I don't come out as 2 3's, I only come out looking like 1. Okay? But I've got to have 2 before I can go through there. Okay, you mean right here under the square root?
Yes.
Okay. Okay, so do you have a pair of numbers that are the same? Okay, do I have at least 2 of them? Okay, so 2 of them gets me out. So this becomes outside as a 4. So my answer, the square root of this. Okay, which what do we know? 4 times 4 is what? 16. So originally the beginning problem might look like square root of 16. And I know that that is 4 times 4. So 4 comes out from underneath the square root. Right. Now, it's a perfect square if when I have a square root of a number and it comes out to be a whole number is when it's a perfect square. Okay? So let's look. Square root of 15. Okay, what number can multiply together to give me 15?
3 and 5.
3 and 5. Are those the same number?
No.
So, can anything come outside? No, they just got to stay under there for now. So is square root of 15, is that a perfect square? No. So if I gave you paper in a minute and asked you to shade 15 squares in a 15 colored little units on here in a square format, could you come up with that? No. I might could do a 16, which would be a 4 by 4, but one of them would be missing, right? No. 15 is only colored. So if you go back and think, I'm talking about in here is going to be 15 total. So could we color 15? Well, there's a 3 by 5. Is that a perfect square? Okay, is there any other way? I can do a 3 by 5. Is that a square? Is there any other way I can do it? I can split it up into 2s. Let me erase some of this.
No, you split into 3.
Split it into 3s. I just did a 3 by 5.
I'm sorry.
I heard somebody say 2s. Well, that's 2 by 7. And then I'd have 1 block. So does that look like a perfect square? But how many units, how many squares are you going to color? 225 squares is what you're going to color then. So the square root of a number is what the little squares are going to be shaded inside. Mm-hmm. Right, because this was a 3 by 3. Let me slide mine up. Well, oh, I erased some of it a minute ago. I was trying to figure out what I'd done. Because I had erased when I was messing with that other triangle right there. There was that original 3 by 3. Because this was 3 by 3. But how many total squares did I color in? 9 to make it a perfect square. So if I want a perfect square of the 15, that tells me 15 of these little squares are going to be colored in. Well, there was 9. Here I can do 12. Here's 15. But is that a perfect square? No, he's a rectangle, but it's not a perfect square. So is 15 going to be a perfect square? No. What else, honey? Nope. Nope. Okay. So that's just kind of the quick reference. Nope. Because that's still a 5 by 3. Okay. So it can't be it's not a perfect square. Okay. Nope. I've got to keep it together. Okay. So square root of 15 does not work. It's not a perfect square. Okay. All right. Now, the other thing, a minute ago we had this. Okay? Now we're going to use what we call exponents. Okay? Now, exponent is this little bitty subscript of a number that I write to the top right. So this is called my exponent. The number, the big number that we always look at is called our base. Okay? Now, the exponent tells me how many times the base gets multiplied by the base. I would. So 2 to the 5th power, what's my base? And I'm going to multiply 2 by 2 how many times? 5 times. So this looks like 2 times 2 times 2 times 2 times 2. Now what is that answer going to be? No. 2 times 5 is 10. Okay, because listen, I've got 5 2's, right? So if I multiply the first 2's together, so 2 times 2 is 4. 4 times 2 is 8 times 2 is 16 times 2 is, so what's 2 to the 5th power? 32. It is not 2 times 5. That is the biggest mistake even high school kids have. They see those exponents and they automatically quickly think that means 2 times 5. No, that means 2 times 2 times 2 times 2 times 2. Okay? Remember, order of operations, when you multiply from left to right. So you have to multiply the first 2, and whatever you get, then you're going to multiply by the next 2. And then you'll multiply by the next number, and then by the next number. Yeah, this is 2 times 2, so that gave me 4, right? So now that looks like 4. Now 4 times 2 was, and 8 times 2 is, and 16 times 2 is, okay, so I got to just keep adding on to multiply that. Yes. Right. All right, let's look at another one. Let's say I have 3 to the 4th power. When they ask for expanded form, they want you to write out what it looks like first. So I'm going to multiply the base by itself how many times? 4 times. So what is that going to look like? 3. So there's my expanded form. So 3 times 3 times 3 times 3. Now, what is my answer? 3 times 3 is? 3 times 3 is? 9 times 3? And 27 times 3? 81. Guys, please be quiet. Okay, so do you understand how we got from here to the expanded? Okay, so now from the expanded, I'm just going to multiply. And you have to take the first two numbers and multiply them. So 3 times 3, and you can write this down. 3 times 3 is what? So I could have had this. Okay, now what's 9 times 3? Now I didn't mess with that times 3, so he's still who to the end. Now what's 27 times 3? And it's fine. There's nothing wrong if you need to write this down. Nothing. Okay? Let's look at another one. What now, Bray? Yeah. Each time I just take away 3. Let's say I have 5 to the third power. Expanded form is what? Which is? Okay, so when I multiply the first two, I get? And what's 25 times 5? If you have 5 quarters, how much money do you have? 125. Okay. Yeah, you could have figured it out right here, and that's fine. Just some people said they saw it better once we started writing it, and that's fine. In the directions tonight, it'll ask you, it'll ask you to write the expanded form. Not solve it, just write it in expanded form. So you're just going to write this and stop. Then there's going to be one that when we go to it, it's going to give you this and ask you to write that in exponent form, which means you're going to write the base and the exponent. So the base is the number that's repeating, and the exponent is how many of those got repeated. Then the third part says I want you to actually solve it. Okay? So you may want to do the expanded form and then solve it. Okay? Now, here's a few key words when we talk about exponents. Okay? Square. Something squared. That means to the second power. And what that means is I have an exponent of 2. So if I said I have 4 squared, that means I have 4 to the second power. Yes. Okay? Sometimes they'll even say something to the second power. That means 2 exponent, okay? Cubed means to the third power. And that means my exponent is 3. So if I said I have 5 cubed, that means 5 to the third power. Yes. Volume is always in cubic stuff because when you do volume, you're measuring length, width, and height. So you're multiplying 3 units. So that's where you get cubes. Alright. The others that you might see, when they say anything is to whatever power, that's the exponent. So if they say something is to the 4th power, my exponent is 4. Whatever it is. Yeah. The only one that has special names is squared and cubed. And squared matches with what?
3.
Squared matches with 2, and cubed matches with 3. After that, it's going to say to the 4th power, to the 5th power, to whatever power. Okay? Anybody have a question? Yeah. Yeah. Now, most likely you're not going to see that now. You might see that when you get to physics. You might see that when you get to calculus and trig. Maybe algebra 2, but I even doubt algebra 2 you will see a power going into anything greater than the 10th power. Okay? Okay? But unfortunately, this square root stuff will carry over from now until you get out of high school because you'll have to deal with square roots over and over. And cube roots. You'll even get into cube roots and fourth roots. Yes. Yeah.